Hey YouTube, I'm making this video. I made a water-fed pole system, a pure water system for a water-fed pole system for window cleaning. I had my own unit that I had ordered from ABC. It was a small portable phaser unit with a pre-filter and then a DI filter on the back of the RO filter. And as I began to look around at systems on the internet, I wanted to see if I could build my own, and so I've come up with this design. I'm putting this video out today to kind of see if anybody has any interest in learning how to build this. I may put it on a Patreon video and then charge like a $5 or a $10 fee, something like that, for people to go to and kind of check this out on Patreon, and I can walk you through the whole process. Everything I ordered, the things that I've learned, some of these parts in this machine are actually going to change. I've been using this for about 2 or 3 days now. And I'm still getting 0.000 parts per million on my TDS meter, and it's got some big filters on it. They're all interchangeable. Nothing about this is proprietary to me. It's all just accessible RO membranes and pre-filters, and then a refillable DI cartridge, which anybody can order. You can find a lot of these on eBay. You can find them from pure water systems that you would buy for residential use, and that's where I sourced most of my stuff. So just in the beginning, I have and I'm kind of squatting down here because we don't have a lot of room with the camera lens. So I've got a hose input on this side, so just your regular garden hose from your building, which goes into a Pentac 20 by 4-inch Pentac housing, which inside of there is just one 20-inch by 4 carbon pre-filter. The carbon because I'm using tap water, I decided to go mostly with the carbon pre-filter on the inside and not a sediment filter on the front end, because tap water is fairly clean, and this thing is also going to reduce some sediment. But the main point of the front end filter is to take the chlorine and chloramine out of the water so that it doesn't affect your RO membrane in the center piece. The center tube is a stainless steel RO membrane. It's a 40/40 membrane. I've got some special fittings on here, and it's got some different port sizes on top, which are important to kind of understand how all of this works. The hoses then comes out after the RO membrane, which reduces your TDS, so your TDS will come out of this about equal to what you have at the tap. At my hose tap here in Kansas City, I have about 260, 270 is my reading usually coming on my TDS straight out of garden hose. After my RO filter, my reverse osmosis filter, my readings were already dropping down like to 0.002, which is super low, and you want to kind of take most of those metals and dissolved solids out of the water before you get it to your DI filter, because it'll make your DI resin last longer. This is the point of the center RO thing. So I didn't understand a lot of this when I started building it, but I got some good advice talking to some different companies about how all this works. And then at the end, I have this DI filter, which is also a 20-inch by 4 refillable canister like I bought a bag of resin, so you can just refill as that goes. I think in the end, what I would like to do is, and one of the things that I'm going to change out on this system is I've put these are fairly permanent linkage. So, you know, I show up my wrenches, I can undo them with wrenches at the job site, but what I'm looking at right now are some quick couplers. And it'll be probably a little different design than like a power washer quick coupler, but I'm looking at a different type, a stainless steel type, where I can remove the hoses easily, because I think this is a problem in all of these systems that I've seen. When your carbon filter goes bad on the front end and you start pushing chlorine through that, I don't know how you test that and know that maybe you're damaging your RO membrane, which is probably the most expensive part of all of these systems. So I want to devise a quick coupler here that I can remove this hose, turn the system on, and then use like a pool chlorine chemical tester and determine whether I'm still getting chlorine. Each time we use it, we could pull that out and determine whether we're getting chlorine or not, and whether that filter is still good. Once I figure out that, then if I can have a quick connect here at the bottom of the RO membrane, if my TDS begins to rise, then I can determine if the rise is coming from the RO membrane or if it's coming from the DI membrane at the end. So I would just, you know, I'm just kind of briefly going over this thing, but I also just want to say, like, the whole system to set this all up probably costs me about $1,200, and I've sourced more equipment now, and I found other places that you can buy it. I'm probably going to build a second unit with a dual RO, And I think this unit right here could be rebuilt for somewhere between $700 and $900, which is cheaper than any of your entry-level things. You don't have the expense of using their proprietary front and back end filters. Even with ABC, I noticed at the beginning of those, we were going through a couple sets of those every month on my phaser, and at 65 bucks on the front end and 65 bucks on the back end, we're about 130 times 2, we're 260 bucks a month. And that is more expensive than a replacement RO membrane in this system. So you can, if one of your filters goes out at a job site, you can refill. If a chlorine filter goes out, a carbon filter goes out at the job site, you can go down to a Home Depot or a Culligan and you can buy a replacement filter and make it work. So I think I kind of designed this to be hands-on and more user-friendly and kind of get us away from using that. It's got awesome pressure. I'll show that in a later video on Patreon, and we can kind of talk about that. But really right now I'm just trying to determine if anybody has any interest in learning how to build this. And I think I could put up a video series on it, kind of starting at the beginning, charge you guys, piece it together, and figure out exactly what I did. But this thing is shooting out super clean water. I've used it on my house a couple times. We let it run for about an hour the other night. I haven't had one variation in the TDS yet. It's 0, 0, 0 all the way across. It's probably been on for 3 or 4 hours now, which is already way better than my unit that I purchased. It comes on a dolly, which is a 300-pound dolly, which makes this a lot nicer than some of the systems that you see. They look like they're almost on like a golf cart caddy, and they're sort of weak. And having been in the power washing business like a lot of you guys, I think you know about those carts, and they typically fall apart. This thing is on a 300-pound Milwaukee dolly that I bought, and I had some welding done to it, and I can talk about all that in my video. It can be run up in the air in a vertical position, or it can lay down in this horizontal position also, and it still operates just fine. So if it needed to go in the bed of a truck and you had it hooked up to a tank in the bed of a truck, I think you could do that. I think you can also get them out to job sites, and you can set it up and you can run it. So just give me a little feedback. Let's see, let's get back in here. Give me a little feedback on my video. Am I in there, Lance? Yeah. Okay. Give me a little feedback on my video and let me know if anybody has any interest in trying to learn this. Just give me a thumbs up, or just tell me, hey, yeah, I'd like to learn how to shoot the video, and Lance and I, my son, will shoot the video, and I'll kind of show you guys how I did everything. Super strong system, man, and so far it's working great. So like for less than $1,000, this is hard to beat. Hit me up on the comment section and let me know if you want to learn how to do it, and we'll start putting the other videos together for Patreon if you guys are interested. Thank you.